As you can see, this is a fairly important definition we have, the point on the terminal side of an angle giving birth to the trig function values of the angle in standard position. And I'd like to take a look in this video segment at quadrantal angles. You could say a quadrantal angle is one whose measure is a multiple of 90 degrees. You could also say it's an angle whose terminal side lands on the boundary of a quadrant, thus the word quadrantal. Let's first take a look at 0 degrees. What you see that stands out really big to me is that there's no right triangle. And so when I referenced earlier, right triangle trig applies to right triangles, this is what I meant. This is where you need to trust the definition that you've been given and that I have restated here to the left of my quadrantal angle figure. Okay, so what we need is a point on the terminal side of the angle that is not the vertex, so we don't want 0, 0 to be chosen. So I could pick a lot of different points. I could pick 1, 0, I could pick 2, 0, I could pick 25, 0, and I could go on down the list. But basically here your point P is a positive x coordinate and a y coordinate of 0, which would make your r value simply the length x. Okay? So if you take a look at x being positive, I'm going to put a little subscript plus for positive, okay? And r being the same value as this positive value of x, then when you calculate the sine value of the angle 0 degrees in standard position, you would have the y coordinate over a positive value for r, which would reduce to 0. Cosine of 0 degrees would be the x value divided by the r value, and it would reduce to a value of 1. And it really wouldn't matter which point on the terminal side you chose, whether it was 1, 0 or 2, 0, the ratios would reduce to sine being 0 and cosine being 1. Okay, so what about tangent and the other guys? Well, let's just take tangent for a moment. Tangent of 0 degrees would be the y coordinate over the x coordinate that we pick from our ordered pair, and that would reduce to 0. But cotangent of 0 degrees would be the x coordinate over the y coordinate, and you would be dividing by 0, which is undefined. Okay? So here's your first look at where cotangent's undefined. Do you see now why the definition makes this restriction that your y coordinate can't be 0 or cotangent's undefined? Okay, now similarly we could do cosecant and secant. Let me squeeze them in here. I'll try to get them over here. Alright, so secant of 0 degrees is either the reciprocal of cosine, or you could start fresh and you have r over x. Oops, hold on. I wrote that down wrong. The r value over the x coordinate, which would reduce to 1, and that makes sense. If cosine's 1, secant should be 1. And then cosecant would be the reciprocal of sine, but the reciprocal of 0 would not exist. You can still see this from the r value divided by the y coordinate of 0, and that guy's undefined. So again, to reiterate, if the guy in your denominator is 0, you don't exist as a number. So that translates into this world of quadrantal angles. If I have an angle where the points on the terminal side have a y coordinate of 0, such as 0 degrees and all the way around to 360, the same thing would apply, then you're going to have these two functions be undefined. Sine and cosine are the only two that are never undefined. So let me reiterate that. Okay, let's look at another quadrantal angle. Let's look at 90 degrees in standard position. Okay, so what's special about 90 degrees in its terminal side? Well, you could have points like 0, 1, or 0, 2, or 0, anybody whose y-coordinate is positive. So I'll use my same little made-up notation here. And if I calculate the r value, which is the distance from 0, 0 to your point, then it's just simply that same length of y. So when I do cosine of 90 degrees, and I do the x-coordinate over the non-zero r value, I get 0. If I do sine of 90 degrees, I get y over the non-zero r value, and it reduces to 1. It's the same number. And then I'm going to have things like tangent, cotangent, secant, cosecant alternately fail to exist depending upon which quadrantal angle we're looking at. Tangent's definition is y over x, so you're dealing with a positive y-coordinate divided by an x-coordinate that's 0. So tangent of 90 degrees is undefined. Okay, now I would like for you to take that one example and continue and do cotangent, cosecant, and secant and reason them out. Okay, make it make sense to you. And I'll do one more here with you. 180 degrees, the points on the terminal side may look like negative 1, 0 or negative 2, 0, and so forth. Okay, so again here what you see is that you have a point where the x-coordinate is decidedly negative and the y-coordinate is 0. This would mean the calculation of r would be the same length as x units, but r is never negative. So when you run through the definition, I want you to remember that the r is a positive number. So if I were to do cosine of 180 degrees, then I'm looking at the x-coordinate, which is negative, over the r value, which is the absolute value of that x-coordinate, and these would reduce to negative 1. The sine of 180 degrees would be y over your r value, and it would reduce to 0. And then you should go through all the other definitions to identify when someone's undefined versus defined. Okay, now this one may have seemed a little more confusing, so let me do this with an actual value here. Let's suppose I use the point negative 2, 0. Then my r is 2. My point is negative 2, 0. So my cosine value is x over r. That's what I mean by us getting a value of negative 1 over here. Now you should follow suit and do something similar for 270 degrees. In fact, just take the point 0, negative 2 and you walk through the definition. Okay, you work it out and then compare to what you see in your textbooks to see if you're right. And then last comment is that 0 degrees and 360 degrees are coterminal, so we're talking about the same set of points. So whatever cosine and sine of 0 degrees are, those are going to be the values for cosine and sine, etc., of 360 degrees. And this is true anytime angles are coterminal. Okay? Alright, so you've got some homework here to finish working through these definitions. Alright, and pick some points on the terminal side and walk it through. Pick a different point, walk it through, and see that you actually get the same values regardless of which point on the terminal side you choose.